In this lesson, we're going to factor trinomials when a is not 1 and they do not have a greatest common factor you can pull out to make them 1. This method we're going to call splitting the middle, and the steps to splitting the middle are written here. I think I will go ahead and work the problem out and talk about each step as we work through the problem. You want to put your trinomial in standard form, highest exponent to lowest exponent. If it does have a greatest common factor, you do need to pull it out. You should always start with greatest common factor. After it's in standard form, you're going to find two numbers that multiply to the product of the coefficient of x squared and the constant. So your coefficient of your squared term and the constant. So in this case, the coefficient of my squared term is 1, the constant is 3. So I want it to have a product or multiply to 3, and I want it to add to my linear term, which is 4. And the numbers that multiply to 3 but add to 4 are 1 and 3. And since they multiply to a positive and add to a positive, they are both positive. That is the pair I need. We're going to split 4r into 1r and 3r. 1r plus 3r would give us 4r. My first term and my constant don't change. But instead of writing 4r, I'm going to write 1r plus 3r, which is splitting that middle term. So we did step 2 and step 3 now. Now I'm going to go to step 4. I'm going to underline the first 2 and last 2 terms and factor each set of underlined terms. So this has an r in common, and I'm left with r plus 1. My next group has a 3 in common, and I'm left with r plus 1. And now each of these have an r plus 1. And when I take out the r plus 1, I'm going to cover up the r plus 1 and r plus 1. When I take those out, I'm left with an r and a plus 3. So you can cover up the r plus 1s and see what you're left with. And that's what goes in the second set of parentheses. I did that with a leading coefficient of 1. It will work with a leading coefficient of 1. It also works when your leading coefficient is not 1. So let's look at example 2. You're going to put it in standard form, highest exponent to lowest exponent. It is. There is no greatest common factor. Step 2, you want to have it multiply to the product of the coefficient of your squared term and your constant. So I want it to multiply to negative 18. And then it has to add to your linear term, and the linear term is the negative 7. So I want it to add to negative 7. And then make your list of numbers and see which one works. So if you get stuck, they need to multiply to a negative. So one's positive, one's negative. It's going to add to a negative, so the bigger number you're going to have to put a negative sign on. So you have 1 and negative 18. That didn't work. That doesn't add to negative 7. 2 and negative 9. There's my pair. There are other factors of negative 18. 3 and negative 6 would also work, but I can stop right here because I found the one that I needed. I'm going to write my first term and last term. Skip some space in between. And I'm going to split this middle term. So instead of writing negative 7n, I'm going to write 2n minus 9n. Notice that gives you that middle term of negative 7n. It does not matter whether I put the negative 9n first or the 2n first. You'll end up with the same answer at the end. This first group has an n in common, and I'm left with 3n plus 2. The second one has a negative here. If you have a negative on the second group, you have to factor out the negative. And these will have a 3 in common. Divide each of those by negative 3, and you're left with 3n plus 2. Now each of these have a 3n plus 2 factor. When I remove the 3n plus 2 factors, notice I'm left with the n and the minus 3. That's what goes in my second set of parentheses. Example 3. There's no greatest common factor. This is in standard form, so step 1 is done. Step 2, it needs to multiply to 60 and add to 17. So you need to find the numbers. If you can come up with the numbers immediately that do that, you can skip writing all your factors out. If you're like, I don't know what does that, let's start writing them. It multiplies to a positive and adds to positive, so both numbers need to be positive. 1 and 60 multiply to 60. 2 and 30. So far, neither of those pairs add to 17. 3 and 20. We're getting closer. Those multiply to 60, but they don't add to 17. 4 and 15. 5 and 12. So it looks like that's the pair I need. And 6 and 10 would also multiply to 60, but I don't need that pair because I found the one that adds to 17. So now I'm going to split my middle term. I'll write 20x squared, skip some space and write the plus 3. Instead of writing 17x, I'm going to write 5x and 12x. That's still 17x though. Okay, so I did step 3 and I split my x term into 2 terms. Step 4 is to underline each set of terms. This first group has a 5 and an x in common, which leaves me with 4x plus 1. You're dividing each of those by 5x. The next has a 3 in common, so you'll pull out a 3, divide each of those by 3. You're left with 4x plus 1. And now I have a 4x plus 1 in each of those. And my second parenthesis, so if I cover up my 4x plus 1, I've got a 5x and a plus 3 that are left over. Number 4. It is in standard form, highest exponent to lowest exponent. They do not have a greatest common factor. I need to find 2 numbers that multiply to 14, and they need to add to 15. So I've got 1 and 14. That's the pair I need, so I can stop there. I don't have to do 2 and 7. So got my pair. Write your first term, and I guess we have n's in this case. And your last term. And instead of writing 15n, I'm going to write 1n and 14n. So that is step 3. Step 4, you're going to group. First group has an n in common. You're left with 2n plus 1. Second group has a 7 in common. Divide each of those by 7. You're left with 2n plus 1. And now they each have a 2n plus 1 in common. So cover those up, and that's what you're left with. You're left with an n plus a 7. Number 5, that is in standard form, highest exponent to lowest exponent. There's no greatest common factor. So I need it to multiply to 66 and add to 25. If you can't come up with the numbers, just start listing them. Start with 1. So 1 and 66 has to multiply to a positive and add to a positive, so both numbers are positive. That 1 and 66 add to 67, not 25, so keep going. 2 and 33. Those add to 35. That's not going to work. So then I have 3 and 22. Ha! There I go. Those add to 25. So that's the pair I need. So I can stop. I don't have to keep finding numbers once I find my pair. Go ahead and write your first term and your last term down. And the middle term, instead of writing 25t, I'm going to write 3t plus 22t. That is step 3. Step 4, I'm going to group each set. The first group has a 3 and a t in common. Divide each of these by 3t, you're left with 2t plus 1. On the next group, they have an 11 in common. Pull out the 11, and you're left with, divide each of those by 11, so 2t plus 1. Now, each of these groups have a 2t plus 1 in common. And when I take out the 2t plus 1, you're left with 3t plus 11. Example 6. This is our last example. This is in standard form, highest exponent to lowest exponent. However, these have a greatest common factor. 4 goes into all of this. So I'm going to pull out a 4. So this is now 2b squared plus 5b minus 3. That 4 is still in the problem, but it is not going to be part of our split the middle. So we're going to look at just this piece right here. I need it to multiply to -6 and add to 5. If it's going to multiply to a negative, one number is positive and one number is negative. If it's going to add to a 5, the bigger number is the one that has to be positive. So I could have -1 and 6, and that's my pair right there. I don't have to find anything else. Go ahead and I'm going to write my first term down and my last term. Instead of the 5b, I'm going to write -1b plus 6b. That 4 is along, but we're just factoring what's inside here right now. We'll put the 4 in at the end. Group, group. The first group has a b in common, and you're left with 2b minus 1. The second group has a 3 in common. Divide each of those by 3, and you're left with 2b minus 1. Now these each have a 2b minus 1. When I take the 2b minus 1 out, I'm left with a b plus a 3. And so the final factorization of this, you'll have the 4, 2b minus 1, and b plus 3. And that will complete our notes today.